Alright, welcome back to another stream. Last time, on last Thursday, we left off in a pretty good place for our reinforcement learning and getting everything situated and planned out. And today it's just going to be doing some of the development work that's needed so that we can save the battle as a state, some sort of information about what's going on in the battle. We need to save it as a vector of numbers, because when we are able to then compress what's going on in the battle into a savable state, just a vector of numbers, we can start our million battle simulation. So we'll be, to begin with, taking 1 million random battles into consideration, and each of these random battlers will at each turn take a snapshot of what the state is for them and what move they're going to use, save it, and then do the move at every single turn. So this is going to create a very large amount of data. So we need to be a little bit clever with how we're designing this state storage, and that's what we're going to do first. So if you're new to the channel, what we're doing is Pokemon Nuzlocke AI. I'm Trevor, also known as Volander AI. I've been doing this for about a month and a half now, and we're getting to the point where it'll be just putting the pieces together. This is the single biggest thing that'll give us the most progress, and once it's done, it'll just be a matter of stitching things together and seeing if it works. So without further ado, let's dive into the planning. So what I'm going to start off with is just creating a new like whiteboard for us to kind of talk about what we're needing to do, because this will help us plan how we're going to write this code. What we need from this is we need to be able to have at every single turn, so if you imagine there's a battle happening, you have one player on one side of the battle with their Pokemon. I guess maybe I'm going to try to draw a Pokemon. Let's see. What Pokemon is easy to draw? Ditto. There we go. Ditto. I'll just draw... Yep, that's a Ditto. Oh wait, hang on. Yeah. There we go. There's Ditto on the field. And the opponent also is there. With their, I don't know, we'll call it a skitty, because that's just a cat, basically. There's Skitty. Or maybe it's a Ditto disguised as a Skitty. Who knows? So, either way, we've got this set up, and the point of drawing this awful visual of the battle is that we want to capture two things. We want to capture both players' viewpoint of the battle, what's going on. At every single battle, we will have two copies of the records of what's happening, so that we can take advantage of what was good and bad on both sides. So this player will see the Ditto, so they'll see all of the stats, so they'll know the stats. They'll also know their other Pokemon, so they'll know all of their other Pokemon that they could switch to. Which there are 5 others. They'll know all of the stats of those. They'll know the current status effects. They'll know all of the actual moves. They'll know, I think last time we said that we didn't really need to care about natures too much because that wasn't going to matter so much. Or it wouldn't matter nearly as much as some other things would. So stats, status, moves, of course the species. what kind of Pokemon they are, what level they are, of course, etc. You have perfect information on your team. Your team is not a surprise to you. That's what this means. However, from this player's point of view, so maybe player 1, you don't have perfect information on the opponent's team. What you see on the opponent's team, so from your perspective, all you see of the opponent's team is what species, what fraction of health they have left, and then everything else that you could know about your team is just shrouded in mystery on the other team. You'll never know the exact attack, HP, defense, any sort of stat. You can possibly find out their moves, but in order to know their moves, they have to use them. Or you can guess, but you won't know until you see them use it. So on and so forth. So in reality, you're not playing a perfect information game. In game theory, this is called, not a perfect information game. I don't know what the opposite of perfect information game is in game theory. Maybe I shouldn't have led with in game theory this is called. Shows you how much of a game theorist I am. But the point is that from a machine learning standpoint, it means we need to be able to do one of two things. Either for the opponent, either we need to guess, or we need to build a model that's okay with nan values, or like blank values. Nan stands for not a number. So basically, instead of giving it any number, 0, 1, 2, 3, 4, you just give it a blank value, a nan value, which is one way of tackling things. Or some sort of other way of doing it. Like maybe if it's a category, where you can have categories 0, 1, 2, 3, or 4, you fill it with -1. So it's a special extra category that means you don't know. So that could be what you do. You could, and these are the kind of two main strategies. Guessing is sometimes known as interpolating. What this is doing is you basically look at existing data and you try to guess the missing ones based off of the existing data. So you could interpolate based off of the mean, if it's a numeric value, for instance. You could try to see, like, okay, maybe you don't know the health, but you know this Pokemon has a range at this level of the lowest possible it could be and the highest possible it could be. So let's just pick the average and assume it's that. And if we get more information, we'll replace our guess. That's something that you could do. But it's a bit harder with categories, like moves. How do you take the average of a move? What's the average move set of a Pokemon? Is it just the 4 most used moves? What if the 4 most used moves of a Pokemon never get used together? For example, if a Pokemon, the top 4 used moves are all damaging moves, then it might be unlikely that all 4 of those get used together, because you'd probably want some sort of balance of damaging and status moves on a Pokemon. So there could be some kind of misleading stats there. The point is that however we store our information, we need to already take this into consideration. Because when we look back on it, after this has happened, we'll be able to fill in some of the blanks. But the important point is that at the time of the battle, the player just did their best. They didn't know. They didn't have the advantage of hindsight to be able to know what was the actual values being used. So if that's the case, then we need to have some support for at this simulation time doing exactly what our plan is. So we need to answer this question today in order to get the simulations underway. And now we can change that later, but it'll be much, much more convenient if we just go ahead and answer this question today of what are we going to do. Okay, moving forward, let's go on to the next part of this process. So, we're doing all of this from one player's perspective, but in reality, we're simulating all of these battles ourselves in the Million Battle Simulator. I'm going to call it MBS. Hope that's not a bad acronym for something else. But the point is that in the Million Battle Simulator, we actually control both players. So this whole thing will be seen from two different perspectives. The perspective of player 1 and the perspective of player 2, who has their own experience and their own things that they see. And it's basically just reversed. They would see the opponent with just a kind of shroud. And even though we could technically cheat, we could tell both players what is on the opponent's team. That's not what you would actually get to know at runtime. So the advantage, at least, is that we'll be saving data for both players. And the way that we'll probably do it is that at each turn, we'll be saving out a row of data. Perhaps to some sort of log. We'll need to be able to have some sort of asynchronous log writing. I think that's not too much of an issue, because writing to a log file when you are running an asynchronous piece of code won't have any sort of race conditions, because asynchronous code doesn't work that way. But it might hurt our performance, especially if there's a lot to write. But I think we're not quite reaching the amount of data that would be like a huge amount to write. So we can time it and see how long does it take to open the file, append one row of data to it, and then move on. Also, there's probably a number of different ways that we could make this very efficient for storage. For example, we don't have to store this as the vector of numbers. We could actually store it as a compressed vector. So take that vector of integers and do some sort of lossless compression on it. We could just store the strings that's associated with it. So instead of storing what integer number Pokemon it is, just store the species of the Pokemon as a text. And that's perfectly fine. Instead of storing a 1 in the column of the Pokemon it is, and a 0 everywhere else. That would help us cut down on storage space and efficiency. The only thing is that later on we'd have to transform it, which, maybe is not the worst thing in the world. So basically our code in the Million Battle Simulator is, this is what's going to be simulated, and at each turn we need to store the following things. So this is again just from one player's perspective, because both players will be doing this independently. So it needs to store the battle ID, it needs to store the player name, so we know which perspective this was from. Okay, so these are the identifiers that tell us whose perspective was this row talking about on which battle. That way, after the fact, we can go back and link this to the result that happened in a battle and know who won. Okay, so battle ID, player name. Then we also need to store several other things. We need to store information about each Pokemon. So we need to store for our team, or for the player team. So for each Pokemon in the player team, we need to do the following. We need to store the species. We need to store the level. We need to store each of the stats. We need to store each of the boosts. We need to store any sort of status effect. We need to store the moves that the Pokemon has. Stats, status, moves, species, level. Oh, the current health. So not just the total stats, but the current health. Of course. And I think that's it. I'm pretty sure that's it for information about a Pokemon. Okay. Then what we need to store is for the enemy team, the species, if known, the level, because that will also be known, potentially. We will not know the stats. It's impossible for us to know the stats. We can know the boosts. The status, we can know. Ability. Yep, ability is another one. So we can also store the ability that the Pokemon has. We can store the ability that the opponent has if it's been revealed. Otherwise, we can't. Because this is, again, not a perfect information game. Species, level... Oh, yeah. And then HP fraction. So we can see their HP as a fraction. So it won't tell us the actual stats, but at least it will tell us generally how much health they've got. Then there's also some information about the field. So we need to store things like the weather, with how many turns that weather has been going on for. We need to store information like field hazards, such as spikes. And that's it. That's it. I mean, I guess we could store something like the turn number, like what turn each Pokemon came out on, because some moves only work if it's the first turn that a Pokemon was out. But I think to train a decent model, we don't need that right now. So let's just do it that way, and that'll simplify things. Okay. So this is all the information we need to store. For species, there's roughly 900 Pokemon. So for this one, there's like basically this is a vector of like 900 numbers. Or if we're storing it in the battle, we could just store the string, and then that simplifies it for us. The level, that's going to be an integer. So this is just going to be one value. What I'm writing here is the number of values that it could possibly have. This level just has 1 because we're just going to write it as a number, whereas species, we're going to write it as 900 numbers, zeros if it's not that species, 1 if it is. This is because integers have relationships, numbers have relationships. 2 is twice as much as 1, and 3 is 3 times as much as 1. But you wouldn't say that Venusaur is 3 times as much as Bulbasaur. They're just a category. It's not something that we want to give a numeric feeling to, so we can't just store it as one number that stores the ID. Instead, we want to keep them independent categories. So it's basically like we'll have 900 categories for is Bulbasaur, is Ivysaur, is Venusaur, is Charmander, and it's just a true or false for each of those, a 0 or 1. So the stats, there's going to be 6 boosts. There's going to be attack, defense, special attack, special defense, speed, accuracy, evasion. So 7. Status. So these are the major statuses, like paralyzed, and poisoned, and badly poisoned, and frozen. But it's also going to hold things like confused and minimized, or recharging, or use protect or something. So we'll store the status, and there's about I think 100. I don't know why I wrote a horizontal line. So there's about 100 or so different status-like things that we can just treat as a status, because to the model it doesn't care if it shows up on the screen or if it doesn't show up on the screen. Move. This will be basically, there's about 800 moves, so this will be 800 values, a 0 if it has the move, a 1 if it doesn't, or sorry, a 0 if it doesn't have the move, a 1 if it does. And we discussed this last time, but what we'll probably do is actually, instead of a 0 and a 1, the number will be the slot that the move is in. If that doesn't work well, if the model that we train performs poorly, we'll spread it out. Instead of being 800 columns, it'd be 800 times 4, and we'll just treat them as 4 separate columns. That'll add a lot of extra data, but that's something we don't have to worry about right now. Current health, that's just 1 value, and ability, that's actually also just 1 value. We can store it as 3. Well, yeah, we'll just go ahead and store it as 3, because each Pokemon has 3 different abilities that they could have, potential up to 3 different abilities that they could have. So we'll just store it as 3 columns. Does it have ability slot 1, 2, or 3? That way we don't have to encode all the different abilities. So all of these, if you sum it up, it's basically 1,800 columns, like maybe 1,850. Just, we can call it 1,800 pretty much, because some of these have such little value compared to the others.
Don't be afraid.
And it's 1,800 times each of your Pokemon. So if you've got 6 Pokemon, then it's like 1,800, let's just call it 2,000 times 6, which is 12,000 values for your team. So for your whole team, it's, roughly 12,000 zeros and ones, or 12,000 numbers, which is a lot of information just to encode your team. And the enemy team, on the other hand, we don't have to even store nearly as much, because there's some things you'll never know. There's no point in even guessing their HP, probably, because the model should probably just kind of learn how these things go. You could try to guess it, but since you would never actually know in a battle what the opponent's HP stat is, or their defense stat is, it doesn't matter. And you should be able to do well regardless. So again, the species has like 900 values. The level, we're just going to store it in 1. I wrote 6s here, but these should be 0s. Boosts, again, there are 7 different boosts you could have. Statuses are, again, roughly 100. Abilities, 3. And HP fraction would be 1. So that's like 1,000 or so. So for the whole team, that's like 6k different columns to store. Weather, plus the different fields, there's like 10-ish, probably less. And then field hazards, I'm talking about things like tailwind and stone edge and spikes and toxic spikes. I think there's like 30 at most. So, that just adds another 40. So, basically, we're looking at on the order of 18,000 parameters just to define the current state of a battle from one player's perspective. And suddenly, with 18,000 parameters, encoding just one turn of one battle, simulating 1,000,000 random battles doesn't seem like it's that many. Because 1,000,000 random battles compared to 20,000 different values that could show up as parameters isn't that much more. 20,000, that's like, it's like 500 times as many for your whole training set to simulate 1,000,000 battles. Now, we'll have 1,000,000 battles, and I think a single battle can go on for quite a while. Like, the average single battle goes on for like 20 turns or something. So, it's really more like 20 million turns of 18,000 parameters. So if we did a quick data estimate, if we open up the calculator, if we type 20 million, so 20 million by 18,000, we're looking at 360 billion numbers to store. If we store them all as a Python float, bit size. I'm looking up the Python float bit size. That's 64 bits. So now we're looking at 23 trillion bits of information that would be stored in 1,000,000 battles. So 23 trillion bits divided by 1,024 is 22 billion kilobits. Divided by 8 is 2.8 billion kilobytes. There, let's work in bytes instead of bits. So 2.8 billion kilobytes divided by 1,024 is 2.7 million megabytes divided by 1,024 is 2682 gigabytes divided by 1,024 is 2.6 terabytes of information. And now this is all very hand-wavy and approximate. Your real information storage could be much higher, it could be much lower. In fact, this is very sparse data. And what we mean by sparse data is that a lot of it will be zeros. And what happens when a lot of it is zeros is that instead of storing just a lot of zeros that each take up like 64 bits, you could just store one number that tells you how many zeros you have. And then reconstruct the data, and you'll be saving a large amount of storage. So in practice, this probably won't take up, 2.6 terabytes of data. But in theory, it absolutely could take up. Our kind of maximum, basically, is 2.6 terabytes. So, And that's because of this encoding. So any optimization we see here, and that we reduce this by, is going to save us a lot down the line. So in this case, we're talking about 2.6 terabytes just to store the training data for a model. So this is just a helpful exercise to see if this number at the end of the day is within kind of the realm of feasible numbers. Then it just kind of confirms that what you're doing is okay. It'll probably actually be much less than this. But yes, so it's 2.6 terabytes for the training data we'd be creating by simulating 1 million battles and storing this each time. Okay, so that's kind of our number. And for the hard drive that this is running off of, we have plenty of space to store that. Right now, the hard drive that this code would be running off of has 12 terabytes free. So there's no real concern about storing it, even if it's twice as much data. But it does tell us that if it really is this bad, there is an upper bound to how many battles we could store and keep the results for. So, and that upper bound is not much more than what we're doing. We couldn't do 10 million battles if it's really this bad for data storage. Okay, so now that we've kind of got the talking part done and we've sorted out how we're going to be, planning this, let's actually get to, doing it. Okay, 1 moment. I thought there was some way of setting a marker. I wanted to set a marker so that I can remember to edit things down whenever I'm editing the video later. But oh well. Maybe not. I need to learn all the hotkeys for what I'm doing. But okay. So let's get to actually doing it. So let's minimize this whiteboard. And let's open up the code editor that we're using. Oh, speaking of which, let's actually start by just doing a kind of callback to last time's stream. Last time's stream we started by pushing a change to PokeEnv, or we submitted a pull request. Oh, look at that. Our pull request was accepted. So the pull request that we wrote 5 days ago at this point, so last Thursday, we solved. And we were thanked and the pull request was merged. So it's that simple. The process, works. Okay. I just was curious about that because I remembered from last time we were talking about it. All right, let's switch our directory because this was the actual PokeEnv code, but we don't want the actual PokeEnv code. We instead want learning. No, it's Pokemon Nuzlocke AI. Yeah. Exactly, because we're going to create this random logger. So what this random logger is going to do is it's going to take the ability, or it's going to take the current state of the battle and turn it into a vector. So let's write this. So our state vector now is just going to be a list. And now we need to store some information about the battle. So I'm going to pull back up this code. And we're going to go to source/pokeenv, environment, abstract battle. What we want is we want to be able to get like the battle ID. So that we can save this as one of the things, because we also definitely need the battle ID. Otherwise, there's going to be lots of it'll be hard to map it afterwards. So we get the player username. Okay, that's good at least. I'm not sure what battle tag is. We can check. Maybe battle tag is, you know, something. Okay, so player username. That's good at least. Let's see. If there's a battle ID. All of these underscore methods are built-in methods. Okay, the battle identifier. Okay, maybe this is what we're asking for. We'll have to see. We'll print some sample things just to see. So what we'll do is we'll say something like get battle ID. So battle ID is equal to battle dot, what was it? Battle tag? Yep, battle tag. And then we also need to get player username. Is going to be the battle dot, probably player username. Yep, just dot player username. Okay, so this tells us whose perspective it is. Alright, now we need to go through for each of the Pokemon. So the way that we structured it before is that we were going to store details about the active Pokemon in one way, and then for each opponent and ally, we were going to store it in a different way. I think this kind of makes sense, and it reduces the amount of information that we really need to bother with. So let's do that. So let's say species is equal to battle.active Pokemon dot species. And then, oh, that's my girlfriend in the chat telling me it's dinner time. One moment. Let's just wrap this summary thing up real quick, and then I'll go down and I'll take a quick break for like 10 minutes. So get the active battle. We need the HP fraction. Battle.active Pokemon dot I think it's HP fraction. Oh, it's in Pokemon. Is the difference. Yep, current HP fraction. Then we're going to need to get the stats. But this is a dictionary of stat to integer things, so we need to just say something like v for k v in stats.items. And okay, whenever I come back, I'll finish up encoding this, and we'll just have it as a big list. But basically, we're just going through each of these things and pulling it from the battle information. So I'll be right back. I'm pretty sure it's just called boosts. We can see right here, say status object. So if we say basic effects is equal to battle dot effects will return basically a list of that, and then we also want something called like if we look up effect, it's a list of effects, and then we can also say def the moves, which again we're just going to encode. Moves is just going to be k for kv in battle.active Pokemon dot moves dot items battle dot active Pokemon dot item. Ability is then going to be battle dot active Pokemon. So we've got embed Poke, and it's going to take in a single Pokemon, which is a Pokemon. Do we have, or we're going to just repeat all of this, but we're going to return a list. So what we'll do is we'll say the other species moves, again we copy paste and then just change battle.active Pokemon to Poke to the item. Okay, so then the last thing is we need to embed things like the weather. Get on with our day. I'm just going to run the active Poke embedding in range Is it maybe like, is this scene better? Like, if this is better for readability, I can try to move my camera around. The issue with this is that
Now my camera will be in the way sometimes on the screen, but if it helps with the zoom, then it might be worth it. I plus 1 is greater than the length of battle.team. It's probably team or something. Oh, this is Pokemon. We need to go back to battle, abstract battle. Def team. Yep. Team does. What we need to do is continue with just running this function. I guess we don't need to keep. We need to do def, like, I think it's opponent team. Yep. Like, telling us what was actually done. That way we know that won't be strictly necessary for us getting something working. For now, what we're going to just do is we're just going to print full embedding, just so we can verify that something looks right. And then we're going to return random move, or random logger player. And now what we're going to do is this to our local host, 8,000. I guess we'll do Gen 8 random battle, because I don't think I have Gen 5 random battle enabled right now. So we'll just do Gen 8 random battle. And we're going to create two things. We're going to do a do I not parse this? The battle order, it ended up telling it to use Iron Head. The very last move on a certain move target. So yeah, we probably want to store the whole battle order so it knows who did it hit. And we're storing all this information, as well as the hail, what Pokemon are there, everything. Okay, and so that's great. This seems like a decent amount. Now what we need to do is we need to turn this into something that is logging to a file. Yeah, append, and then it's very straightforward. It's a lot more clear what's going on. I'm gonna open it up in a different editor so we can see. So we can see battle Gen 8 random battle and then the ID number. Great. So this has the ID number, and then it has the player username, which is also great. After that, it has the weather, and then details about the first Pokemon. Details about the status of the Pokemon. Right now, status of the Pokemon. Right now, it has none in there, so it's showing none. Maybe we want to get rid of that. And then for the boosts, the 7 boosts, it's not boosted at the start. Has no status effects, which is why this is a list of none. And then it has these moves. It's got a choice scarf. And then its ability is Swift Swim. I don't know why its ability is Swift Swim, but okay. Berserker, level 86, full health. It's showing no boosts, with no status, moves, etc. Okay, I want to see with an opponent Pokemon what it lists for the moves. Okay, at the start, it's just listing none for everything. Except no, there's, again. But I'm not sure why. What caused the slowdown last time, as things weren't strings. Yeah, and so luckily my job right now hasn't been too hectic. Like, we've had a lot of meetings at the start. Like, I just started a new job like 2 weeks ago. It's struggling so much. Challenge people on Showdown. Even if it's not doing it for training, it's just doing it manually while we're seeing. But we'll also have definitely a YouTube video dedicated just to playing it and seeing how it does right now. Or after it's trained on these random battles. And see how big is this log file going to get. So, if we assume that this log is fairly steady, in fact, actually what we can do, I'm going to go ahead and delete everything that's in here. I am going to speed it up, which it's going to start getting larger and larger to read. Like, obviously, we're not feeding the random battle this information. This is just so that we can map it to the result. It's not going to understand these brackets. We'll have to turn this weather into something else. It's not going to understand melodic, the Pokemon. It's going to need it to be a like one-hot encoded category. These columns are fine. Anything numeric is a-okay to just directly go in. It's not going to understand what this is, that this means no status effect. So we'll have to encode that. You can see the moves. Again, the moves are also strings, so those need to be one-hot encoded. Leftovers is a string, competitive, which is an ability, is a string, and then the next Pokemon, and it goes from there. And if we look at the opponent Pokemon, we can see a whole lot of nuns, because it doesn't know. So you can see also with this, if you look at the ID number, you can see this ends in 910. If we look just a little bit lower, here's 910 again. So this was the first move, and then this 910 down here was the second move. So then we can see that like the first move, they used Recover and Dynamaxed. The second time, they used Toxic. And did we have more information about the opponents? So at this point, trying to see, because we didn't really store this in like a very readable format for people. There's a lot of nuns, and then we can see Comfy with some information in there, which is one of the opponent's Pokemon. But everything else is just generally none. We can see Unknown Item, which was a special tag for... Oh, dang it, got away. Notepad is not the best editor for viewing this information. We'll view it programmatically later. But, it was storing like just what it knows, and if it doesn't know what belongs there, it just does none. Also, I've been told that my stream quality is a little bit low right now, so I'm going to grab a Ethernet cord and plug in. In the meantime, I'm going to Yeah. So this is the log file. You can see it's the same type of thing, but now for the same battle there will be random player 2 and 1. So both sides what they see. And our idea is that maybe by looking at both sides we can benefit. So if something good happens, we can train the model both what happens when something good happens and what happens when something bad happens. Like, how do you choose the right move and how do you not choose the wrong move? But how does it know just from a single move what was good and bad? Well, that's where the kind of scoring the game comes into play. We can do this a couple of different ways, based off of how readily available the data is to us in a helpful format. So what I mean by that is that if it's easy and fast for us to be able to look up exactly what happened in this battle, then we can create a complicated score based off of how much health all of your Pokemon were left with at the end of the battle. Obviously, was it a win? Was it a loss? Was it like a Pyrrhic victory that like you were hanging on by a thread? It was just because of like a lucky miss that you won, etc. Like we want to be able to get that information. So let's check the Pokemon Showdown logs and see if these get stored. Unfortunately, I don't think most logs do get stored. So we might need to have logs get fully stored for all battles in order to be able to read them. As in, we might have to save replays so that the log challenges thing. Challenges. Log challenges. There we go. So we're going to log the challenges. True. And we're going to need to reboot Pokemon Showdown in order for that to take effect. Which is this file. You can see that the name of the log is Gen 8 Random Battle -2294115, and here Gen 8 Random Battle 2294115. So this will check this log for the score. What we'll realistically do is we'll write some sort of script that reads all of the Pokemon Showdown logs, because the same battle will show up over and over and over again. In fact, since this battle was 42 turns, it will show up 84 times. So we don't want to have to read the log and compute the score 84 times. We want to compute the score once and save the score to all of these 84 rows. Okay. .6 days. Let's see if this performance increase open up like Task Manager and see what's getting hit hard. Like the disc is probably getting hit hard, like one disc is probably getting hit hard, which is the archive disc, which is... We've simulated 900 battles. Let's go ahead and just it like from TQDM, import TQDM. Okay, there's all the imports that we need. Now let's just set some paths. So path to logs, copy my path to my log file. Archive hard drive, which is why there's MBS log, which is our Million Battle Simulator log. I'm gonna get the path to that now. And this is going to be, yeah, log. Alright. So we're gonna say with open path to MBS log. Also, I'm not gonna be very funky. I'm just gonna say MBS lines dot append line. Being instant. We can see, though, that the RAM barely budged. Only by the slightest amount budged. We've got MBS lines. If we just check out like the first one. So actually, you could probably do this no problem, all in RAM. Now what we've got MBS lines. If we just check out like the first one, we see it's like this big string that we need to process. So now we need to write a function that can process a line. So this is going to be items in it. A random one. Oh, it increased to 194. So we need to find out why. Why is the length sometimes different? Because the length should be consistent. So why is it that sometimes the length is larger? And my guess is that it has to do with some of the objects that we are storing are getting printed with commas in them, and that's no fun. So if we look at line, let's look for the extra comma that might be there. My guess is it's... Oh, wait. No, it's just there's commas in these lists of moves. That's why. Duh. Do I want to deal with that, or do I just want to use a custom separator? I just want to use a custom separator. Definitely, definitely. Just want to use a custom separator. Okay, so that's not bad. Unfortunately, we do need to rerun our code that created the log file, because what we're going to do is instead of separating things with commas, like we've been doing, we want to just be able to simply break apart things. So we're going to delete all these logs. We're going to go to the generate random battle folder, delete all those logs. Oh, oops, I just generated more. Oops. I meant to run Jupyter Notebook. So that's going to be like the Journey to Gym 2. So it'll be a little bit more of an entertaining video. I'll probably not do so much educational stuff in that video. It'll probably be more just the entertainment factor of having a model. I'll still explain what the model is doing from a very basic standpoint, but most of it's going to just... So why is there difference? Let's see how drastic the difference is. For I in range 100... Let's see if it's just that there's some examples where they're different. Okay, all of them will be doing that. Plus 7, which is 15. So active stats should have 5 items. Active boosts should have 7, because there are 7 different boosts you could have. It's the 5 plus 2 for evasion and accuracy. Active statuses we are embedding as a list, so there should just be 1 in it. Def team. It's a dictionary of Pokemon. Yeah, so it's just a dictionary of Pokemon. Just can't think of what it is. What would be adding up to like 15 extra entries? I'm gonna Control C, and I'm gonna switch it to print. Allies. And then lastly, one more assert statement that we added was up here. Let's close out of a lot of these files. We don't need a... Unexpected length 19 in processing active Poke. So we expected, when processing the active Pokemon, to get 8, 15... 19. Wait, what? 8 plus 7 is 15. Plus 4 is 19. Huh? Why is... What? 3 plus 5 is 8. 8 plus 7 is 15. 15 plus 4 is 19. Oh! I'm dumb. Hang on. I'm checking if it's equal. I'm supposed to check if it's not equal. Duh. That was just printing all of the cases that it's expected. Yeah, that'll do it. Yeah, I just had the if statement the wrong way. It's supposed to be the other way around. It's if it's not equal. Sometimes you get a little bit too caught up in your code and you forget what you're doing as you're writing it. Okay. So let's see here. It's not happening inside of the embed Poke function. Is that this should fill it with 14 blinks, not 13 blinks. Okay, so that's one. Oh, and that seems to have reduced some identifier. I don't think we can get the identifier from it. Slots, there is, doing this just for random battle simulations. What's happened? So it's def active. Yeah. If it's active, then we skip. Because we already got it earlier. Maybe that'll just be enough. So if how, like, so that's what's happening, is it's adding an extra... It's adding the active Pokemon twice. As battle.active Pokemon. Let's print team, and then we're gonna print in there. Okay. So, either Scrafty, Turtonator, Tangrowth, Thunderous, and Gardevoir. Okay. You know what? I'm seeing a pattern here. Gardevoir, Gardevoir. Quagsire, Quagsire. Sandslash, Sandslash. Pikachu, Hoenn, Pikachu, Hoenn. Virizion, Virizion. We need to clear our logs because we'll have some junk data in our logs. Like envious lines. No, there are lines that are getting printed. How many lines got printed? Was it all of them? Doesn't seem like it. Line in enumerate. We're gonna print E length of oh, it's 177, not 170. This is all of them. Okay, false alarm. False alarm. Alright. They're all supposed to have 177, not 170. Okay. Good. Good, good, good. So now we need to process this line. And this processing raw line is just going to be turning this into not categorical data yet, but something that can be stored in a pandas data frame. So that means flattening out any sort of list and processing things in the right way. So now that they've all got the same thing, then it's really easy. So what we're going to do is we're going to say something like line is equal to MBS to that. And now we need to start pulling things out. So battle ID is going to be split line 0. Details is equal to 2 Pokemon that's there for I in range 11. And if we check out other Poke details, -1, none, 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 none. If we were to then kind of reconstruct this all, if we were to say something like the length of battle ID perspective, this is just to test it real quick, we don't need to leave this code in, weather plus active Poke details. So that's 22 items, which makes sense. And then if we were to then do, we need to flatten this thing. Plus the sum of the length of E4D in other Poke details. 177. Uh-oh, we're missing something. And that's not going to be too bad, actually. What we need to do is we just need to take in this line. Like, if we look at active Poke details, for instance, this is the statuses. This could potentially be multiple statuses. And that's it. It's just the statuses and the moves. Those are the only things that are a list that are potentially flexible. So what we can do is we'll say something like, actually, you know what? Whenever we first read this, let's not even let's not even worry about it. Because we can flatten it out later, having it all in a pandas data frame. That's perfectly doable. So we're going to return a dictionary, which is going to be yeah, we're gonna create a detailed dictionary. Dict is gonna be an empty. All of this nonsense, we're gonna say something like detailed dict battle ID, detailed dict perspective, detailed dict weather, then we need to add each of these things to say detailed dict, let's take active Poke details and print it again. Active species is going to be 2, 3, 4, 5, 6. Oop. This is the level. This is gonna be the HP fraction. I could have, for the logs, searched for conversion, like ingesting and output, probably would have been better, but it would have increased the time to write files, because we wouldn't be able to just write it one line at a time. And it would have increased the size of the file. So it's a little inconvenient, and if we change the structure, we'll have to change it in both places. But we're probably going to have to do that. Special attack, special defense, and speed. So 4, 5, 6, 7. F boosts. Boosts. Let's see. Oh, it's in a weird order. Okay. It's accuracy first, for one. It's in defense, because it's evasion. Okay. So then there 12, 13, and 14. After the boost is then the statuses. Is equal to 15. Which will take in a details, and it'll say something like D, and we'll repeat this kind of thing. So if we look at other details 0, then we're going to do species, level, HP fraction, which some of this we can just copy. All this stuff we can copy. But we probably don't want to. Species, level, HP fraction, for details 0, 1, and 2. Then we don't process the stats, but we do process details. And each of these are going to become 3, 4, 5, 6, 7, 8, and 9. So we've got each of those. detail dict tag statuses is equal to details 10. Detail dict tag moves is going to be equal to this list. Which is 11. But actually what we want to do is always have it be a list, so then it gets exploded out in the right way. So if we compare len of details, actually, we'll just, that's fine. We'll just say details 10 or no, as a list, just that way it's the same format. If the moves are unknown, then we want details 11 or an empty list so that we can expand it out properly and we won't have formatting issues. The item, I don't know when it's what, so it's then details 13, which is our last one, is the ability. So now we are kind of we want to kind of get a good enough model by pre-training it off of some random simulations. And this is us building something that can process that. Once this function is done, it'll be able to show the log here. For reference, by the way, my name is Trevor. I'm a machine learning engineer for D in enumerate. Other pokey details. We're going to say pull other details. I guess I can just say E. It's fine. D. And then lastly, we just need to say detail dict move is that, and we will return detail dict. So now let's run this whole process raw line. It's been going pretty well. Today we've been kind of crushing it in terms of performance, and hopefully Thursday will be the master's program. But yeah, I typically use TensorFlow, specifically Keras, and like it's just the most comfortable for me. I can learn PyTorch if there's something I need to do for it, but I've found that everything I need to do I can use Keras for, and like TensorFlow in general. I usually start stream like 6:30 p.m. my time in Japan. I can check 6:30 p.m. JST to EST. That's 4:30 in the morning Eastern time. So that's fairly early, but I also upload all of my VODs to YouTube as well. Yeah, and like AI, especially TensorFlow, it's crazy how managed it is now, and how easy it is to get into using it. Okay, and so it seems like our data parsing script works pretty well. It's, like, we can just... It's none else, details 3. We're gonna copy-paste this over and over again. definitely a very changing industry. My long-term girlfriend, she was in the background earlier handing me cats. I don't know if she was visible on stream, but her dad has been doing AI since like the 80s. And whenever we've talked about AI, it's like we're speaking completely different languages. Like, his whole perspective on everything and what AI means to him is way different from me. Like, for him, basically any conversation about AI is about robotics. Because that's what he was doing whenever he was younger. It was all robotics. Which is gonna be just none if details equals none. Else details 9. Yeah, unfortunately these lists are actually just strings that look like lists. Is that what I can use eval for? No, that's not what I can use eval for. There doesn't really seem to be unknown item. I mean, she is technically part Japanese, but neither of us are from Japan. So, like, yeah, we're both pretty basic American. After a bunch of interviews, it was like a 6-month-long process. It was crazy. But I got in. I got accepted after like the basically 6 months of wait. And I came here. You know, it's been fun, but I haven't really been doing a huge amount of like exploring Japan. Okay, I think that's every kind of edge case covered. If I run that again now, we can see everything is a string. Except for the none things where they're handled now. And if I build this up, like the goal is to build this into like a pandas data frame. So now what we can do is, like, certainly this battle ID, that's going to be for getting the score, which is going to be our Y, what we're predicting for our model. And everything else is going to be for, like, basically everything else, like the inputs of things, and, you know, say everything's all nice in the US. I completely recognize in the US I'm very privileged. I do not really face much racism that people do. But it has been really weird and really uncomfortable in Japan at times, experiencing overt racism. For example, when we were trying to find a house, we got rejected from multiple places for being foreigners, and the reason they tell you is that they don't want to rent to foreigners or non-Japanese people, and that's completely legal. That would be against the law in the US. People might do law in the US. People might do it, but make up a difference. Or we don't want non-Japanese. It's kind of crazy just to see it, you know, just out there. Okay, so we can see that some Pokemon get used a whole lot in our data, and some Pokemon show up very little. Now, our data, all in all, if we look at our DF, we've got 57,000 rows of data with 166 columns. We're gonna start exploding that out in terms of columns, though. because we're going to be adding columns for all the different species of Pokemon you could have. Adding columns for the level. Well, not, sorry, the level, but the moves that you could have. The easiest way to do that is not try to create a perfectly exhaustive list of every possible from the log file, and it's working. So we may as well just start simulating it. And just let that run in the background. And then if we want to kind of restart and run everything, we can load in more data and get our things working a little bit better. But let's check some more stats. Has some sort of strange approach. Yeah, so actually both the companies I've worked at have been really international. So in the office until like 11 o'clock at night, like at least once a week doing that type of thing. So I think it really does happen, and it especially from a working standpoint, it can be a really toxic work culture if you're not lucky. Okay, well, let's start expanding this out. So what we need to do is interpret this data. So the weather stuff, if we do something like .str split dot actually maybe not split, but maybe find. I want to if W is equal to in df weather. There we go. Is NA. Okay, so that fixed it. So this weather cleaning is NA. All is NA? I guess actually instead of saying none, we shouldn't have it be a none, we should just have it be none, like literally the string none. So I'm gonna cut this up here, do that, and print df. Like the person who went onto a primary, so, and even she was surprised by it. So I think the attitude is changing. So if we were to look, so let's go in order. Active statuses. If we check out 0, it's a string, this into an actual list. So how might we do that? So if s is equal to none, neat. Okay, so it would kind of work. Status dot strip. Yeah. Okay, so this tells us like the status of the Pokemon, and this is as an actual list now. So it's an empty list if it's just actually that it happened on. So here we can do a similar trick where we say something like dot split dot -1 dot split colon 0, and we are just extracting out exactly what it is. So now you can see that we've got Faint, Dynamax, and Max Guard. sticky web, and confusion, all of that. So this is information about the statuses that are affecting our users. This was a massive list comprehension. Doing it all in one list comprehension is not readable, but we're just exploring our data, so I say screw it, let's just do it. So let's say active statuses is equal to that. And what we're going to do is we're going to say status calls is going to be equal to active statuses actually, I'm just going to say active statuses plus f-string I underscore statuses for I in range 11. For status call in status calls key error. Oh, oops. This isn't supposed to be the string status call, it's supposed to be the variable status call. Now if we check out df, you can see now if we scroll over to the side, yeah, it's the column looks the right format. So it's a list that just has some sort of information. And this is a list of strings that apply. And we've done it for each. Ability is the last one. Ten moves. Oh! Accidentally had moves show up twice. I wrote moves twice. I had moves here and moves here when I was supposed to have moves and then item. Okay, so it wasn't like a deep issue. I was a little bit worried that it was going to be a deep issue, but luckily it wasn't. So always have to have 4 items. So what we'll do is we'll write another list comprehension. So we'll do something like move list 1 to -1. Like if we do something like df 10 item dot value counts, is it ever not unknown item? It's always unknown item. Okay, so it's never revealing itself, but it might just be that we have a small enough sample that the item is always unknown. What about 9 item? 9 item gets known sometimes. So it could just be a random odds thing. Yeah, so we need to clean up move. So if we have, for example, a move, what can happen is that it's either going to choose to use a move and Dynamax, or it's going to choose a move and not Dynamax, or it's going to choose to switch and switch to a Pokemon. Those are the kinds of things, and but we need to kind of find a way of structure, like splitting up this string into what would be a good way of doing that? Oh, also, I just checked our Million Battle Simulator log is at 2 gigs so far. And it's growing pretty rapidly. We're at 14,000 battles simulated. So it'll get to 1 million by the time we stream next. Hopefully, by the end of today, we can have everything ready so that Thursday, it's just about training a very basic model first and playing it. Viewers can play. I'll take a crack at it. It'll probably not be very good. It will likely not do very well in battle, but it'll still be neat to try it out. Okay, what do we want to do next? I'm trying to think if there's a general order we should do things in. Yeah, I guess let's just let's clean up the move. That's a good next thing to do. Okay, so what we need to do to clean up the move is that the move details could be 3 different things. This will be expanding out the move into multiple things. So the columns will be things like use move, thing like actually we'll just say something like choice, which will be a 0 if it's using a move, a 1 if it's switching, pokey, and then the last one we'll have is Dynamax. So Dynamax is really easy. We're just gonna say it's 1 if actually no, we don't even have to create a list. We can just do something like df move .str.contains Dynamax. Okay, so it'll just be if it contains Dynamax. Choice will be, does it contain switch? And then next we need to be a little bit more clever. Like if we just run this and we show what those 2 columns look like, you can see it's just based off of what's going on. So the choice is false here because it's doing a move. The choice is true here because it's doing a switch. The move to use will be df will be not df choice, is going to be df move dot string dot split, and then we want to always select the 3rd item. Pandas string, or no, pandas slice list in column. This isn't quite what we want. Pandas slice string. Oh no, that's just gonna be... This is... It's so close. This is very, very close to something that we can do. But I'm not sure that it actually is something that we can easily do. Series.string methods, series.date methods. Instead of doing that, we're gonna say length of s, or we're just gonna say and then now we're gonna get the min. So 2. At some point it's 2. Why is that the case? $10,491. Move. Choose default. What is default? Pokemon Showdown. Pokemon Showdown. Game API. There's like a game API you can use. In the simulator, maybe? Default. To auto-choose a decision. Okay. It just auto-chooses. So maybe we can just select... You know what? We'll have a special case for it. We'll have a special case. df default something like that as the same column, but instead we can't, which is a little bit annoying. Well, find some other way around it. What we'll end up doing is we'll have a move 1, 2, 3, and 4, and so it'll be a 1, 2, 3, or 4 if it's the move 1, 2, 3, or 4 that you have, and then if it's a Pokemon, it'll be 1, 2, 3, 4, or 5, depending on which Pokemon you have. But that means we need to do move processing before we can finish up selection. Dang it, I knew I should have done the move stuff first. That's why I was trying to think of what stuff should I do first. Oh well, we're coming along. Okay, so we've got that. Ooh, we hit 20,000 battles. Yeah, that is technically an action you can send. You can send a forfeit. It'd be kind of funny if we just created a model that forfeits whenever it thinks it won't win. It rage quits. We can also send chat messages from within a model, or from within a Pokemon player. In fact, it just assigns each string a unique number. So it's very easy. So what we do is we say something like, we need a weather label encoder. we would then do, you see, it just assigns them numbers. Like, you could absolutely make your own label encoder really easily using just like, you know, create a set of all the unique items and then just sort them and give them a number. This is just a helpful, you know, very, very simple approach to that. So now what we can do, plus you can also like fit it on like multiple times. Is just the amount of data that you can get on users, that modern companies have on users. Privacy from your internet service provider. Based off of the things that I've seen, companies really can build a user profile using your search history. Like, they typically have it anonymized, if it makes you feel any better. Like, they typically don't associate your name with your search history. But you as a user profile, they'll have things like, what are your most used websites? And they have a very big list, and they do not filter out adult content on those lists. You know, it was interesting to see it, and like, I couldn't just look it up for, you know, anybody I wanted to. It was all anonymized, but that information about you is not anonymized somewhere. So you know, it might be ethical to anonymize it, but I feel like it's a little bit unethical to even use all of that data without people really realizing it. Yeah, but they just, they can know a whole lot. Anyways, now we can just do something like df weather is equal, and now it's been turned into a number. Domain of ML, I mean, I do a data. Okay, so we've got that, and now we want to create a Pokemon LE. So we'll say Pokemon LE is going to be equal to another label encoder. LE.fit. And I believe we can call fit multiple times. Otherwise, we'll just concatenate everything. Oh, and it's not Pokemon, it's species. All classes for P in df active species. Shoot. We might not be able to fit multiple times. So we probably have to concat. Oh well, we'll just concatenate them. That's fine. let's see. Right now is species. For call and species calls. These calls. Call is DF call. And I guess instead of there we go, and now you can see the active species is again also a number. And it's the same for each of the Pokemon. Now if we were to do something like DF 0, no, I don't want it to get cut short. I want to print the whole thing. Like maybe whatever. I'll print it as a list. And then this one is going to be ability. We need to turn these into numbers. Everything will just be turned into a number. Note. Like if we check out, locate. Okay, it got rid of the extra double quotes that was happening. And the statuses don't have an extra double quote. Nice. Does have an extra double quote in it. The moves, if the move list is empty, move call is then equal to if move list, like if the length of move list is equal to 1 and move list at 0 is just an empty string. Else move list for move list ADF move call. Alright, let's see if that fixes the empty move lists having just like a single string in them. If we scroll all the tag, move DF, tag, none if, move, if the length of move list is less than 1, else move list 0 for move list in that. Now what we can do is if we copy this whole big thing, what we're doing is we're extracting just and the third move. And if we look at that, then, and then for tag, there we go. And now, as we find out the opponent's moves, we'll be able to label them. Otherwise, if we don't know their moves, we just won't label them. Now what we need to do is label, now let's repeat this. Actually, you know what? No, let's label encode. So what we're going to do is we're going to label encode is going to be, again, a label encoder. Move le dot classes. So these are all the moves that it was able to find. Shape. So it found 298 moves. It's a decent amount of moves. Okay. And now we need to repeat. And we need to say for move call in move calls. This is much trickier. We can't just copy paste the exact same code and expect it to work. Way, which means we might have to just already know how many there are and one hot encode it. So what I'm gonna do is I'm gonna say unique statuses is equal to an empty list. I'm gonna say for tag in rel tags. We're going to have this be a set, actually. This might not be the most efficient way of doing it, but status effect. And some things like protect, like did they use protect on the last turn, count as a status, because that impacts whether or not you're able to use protect again this turn. So there's lots of statuses they could be stacked together. Like, in effect of them, there's a status or a side condition or effect, as they call it in Bookian, that deals with that. So either we try to determine what moves have been used in the past and whether they had an impact, or we just kind of brute force it like this, which is not terrible, but I'll put a sometime. Never mind. I guess our data size is still pretty small. So yeah, here's all the different status effects that it found. $49 different statuses. So what we can do is not quite a one-hot, but a multi-hot encoding of each of these. Status multi-hot is going to be a zeros vector of size status le dot classes dot shape. And then what we're going to do is we're going to say for status in status list status multi-hot at we can do this loop in NumPy. So it shouldn't take that much longer than anything else, because we can do status le.transform status list is going to be equal to 1.0. Status matrix is going to be an empty list. Is this not Boolean type? Okay, yeah, it takes substantially longer. Why is it 255,000 rows though? Shoot. Status df is going to be equal to pandas.dataframe. Columns is e.classes. Tag under status under class or c for c in that data is equal to status matrix. Status d. So if we wanted to do 1,000,000 turns for training, we've already surpassed that threefold. Okay, so now you can see active status aromatherapy, active status burn, active status confusion, etc. There's 588 columns, one for each one. Active status wandering spirit, active status type change, etc. Okay, so also several of these conditions probably can't apply to swapped out Pokemon. Like, maybe like disable, or confused, or encore, or substitute. Some of them can, but if we look up Keras to categorical, there we go. There is a function that can make this a lot easier, so we can say from tensor flow.keras.utils import to categorical. What to categorical will let us do is something like this. To categorical df weather for tag in rel tags. Species df is going to be equal to, again, this same kind of thing, but we're just attaching some helpful names so that things are human readable. This is going to be a massive data frame in terms of columns, so it doesn't really actually matter too much that it's human readable, but you know, it still helps. Tag underscore species. And this shouldn't be too slow, though. F string. Statuses we've already got in the status df, but we can instead of building this big... Well, we've already got status df with everything. So we'll skip status. But moves, we did active move 1, 2, 3, 1. Move 1. We're just gonna actually just do multi-hot encoding, actually. Two, three, move 3, df plus move 4, df. Each of these individually would be a 1-hot df, but we're just stacking them on top of each other with the same column names so that it's multi-hot instead. It just saves us multiple thousands of columns. So we've got the moves, and an item, and ability. And is that it? Yes, that's it. That's those are the last two ones. So I'm gonna pull this again. Item df. Item. Oh, we need to change all of these from species LE to axis is equal to 1 observation df. Oh, oops. Where is this happening? Species df. There's a slight misalignment on off by 1 error. So what we need to do is we need to say num classes is equal, because I misspelled it. Okay, 12,000 columns. Okay, 12,000 columns. And you can see it's things like hail, none, rain dance, sandstorm, sunny day. So let's clean that up for weather. Instead of column, we still need to do the tag thing. So for tag level, we just copy it directly. Tag level. And it's no problem. Tag HP fraction. Let's go to HP fraction. The attack, defense, etc. Like the boosts. List df.columns. These two as type float, as type int. Just that way there are actually numeric types. It's ones that make or the 5 ones, not 6 ones. The 5 ones that make your active Pokemon unique because you know the actual stats. int argument must be a string, a bytes-like object, or a number. I guess we can just do float. It's fine. Nice. Let's attach as type float to the ends of each of these. And these 12,586 columns are our input columns for the observation of the game state. So we went from 177 for the compressed format to over 12,000 for our detailed format. And this is format that we can almost directly feed into a model. We'd want to for call in observation calls if well we'll deal with that next time. Okay, so we've got our training data ready. So that means in 2 days, like let's see, it's at almost 50,000 battles simulated. So it's still increasing. By Thursday we'll have 1 million, and we'll just be running all this again more intensely. We can just to do it, let's go ahead and restart and run ourselves. And see what this is looking like. Yeah, so by the end we were at like 19 gigs of memory usage, probably because of all of our like multiple copies of things and running things multiple times. It's climbing in memory usage. Let's see where it's at right now. Okay, so it is 5.9 million turns of data. So it's processing everything. I want to add a TQDM here. Any loop I want to add TQDM to. Yeah, now instead of it being basically instant, it takes like 6 minutes to pre-process. But alright, I think that about wraps up for today's stream. It's a little past midnight here. We're at over 5 million, almost 6 million turns of battles simulated. Our data is structured in the right way for our input to the model. So on the start of the day, Thursday, what we'll be doing is just getting our output to the model structured, which will be very simple. I think to start with, we're just going to do or yes and no who won, and the model will just try to be has been done to this kind of level of detail. So I'm excited to see where it goes from here. Hopefully we can have the world's first kind of real Pokemon AI.